Hi guys, welcome to the channel. So in the previous video we were discussing about the classical procedure which we need to follow in order to find the molecular formula of any given unknown organic compound, right? And there also we discussed that we need to follow three steps, and these will be like qualitative analysis, quantitative analysis, and molecular mass determination. Now if we look at the third point, that is molecular mass determination, then we discussed that in nowadays, like in modern era, we use molecular spectroscopy, sorry, mass spectroscopy. So for modern times we have mass spectroscopy, but in classical ways, in classical techniques, when mass spectra was not there, how we were able to determine the molecular mass of any unknown compound? So that we are going to discuss. We are not going to discuss in elaborate way, we just need some bits and pieces of knowledge as to how we were able to determine the molecular mass of any organic compound. So quickly we will go to these methods one by one. There are three major methods which we want to discuss. So we will move on to these three methods one by one very quickly. So method number one is vapor density method. In vapor density method, what we are going to do, we will take known volume of gas at known temperature and known pressure. Now suppose we are taking any gas and we know the volume of that gas, and we have taken that gas at known temperature and pressure. Now we are going to convert that gas into some volume of gas at standard temperature and pressure. So initially we took known volume of gas at some known temperature and pressure, and then we converted that gas into a volume which was at standard temperature and pressure. Now we can determine what fraction of a mole that the volume represents. After conversion, we can determine what fraction of 1 mole of that volume represent. From that fraction, from here, whatever fraction we are going to get, from that fraction we can calculate the molar mass or molecular mass of the unknown compound. So this was the first method. Take a known volume of gas at known temperature and pressure, convert it to volume of gas at standard temperature and pressure. From there we can determine what fraction of 1 mole that gas represents, and from that fraction we can calculate the molecular mass. This was the first method. Now moving on to the second method. We just need a bit of understanding. We don't need to go into the further details of it, because nowadays we use majorly mass spectra, right? So method number 2 is cryoscopic method. In this method we will take known quantity of test substance. So known quantity of test substance will be added to any solvent, and depression in freezing point. I hope this term is familiar with all of you guys. Depression in freezing point is measured. So initially when we are having some type of solvent, it will be having a freezing point. After that, what we will do, we will add some known quantity of our test substance to that solvent. After that, there will be depression or decrease in the freezing point of overall solution. We are going to see what is the amount of depression in freezing point of that overall solution, and from that we are going to calculate the molecular mass. So this is the cryoscopic method. After that, we have third method, that is vapor pressure osmometry. In this, what we will do, we will examine the change in vapor pressure. As the name suggests, vapor pressure of solvent when test substance is added in it. So in this method, we are going to examine the change in the vapor pressure of solvent. So similar is the case here. We were noticing about the freezing point, the depression in freezing point, and here we are going to check what is the net change in the vapor pressure value of the solvent when test substance is added. So these are the three basic methods which were used initially to find out the molecular mass of any unknown substance. But now we have to keep 2-3 points in our mind, that you can take these points as note, that if the unknown substance contains carboxylic acid, then it may be titrated against NaOH solution. So we can do the titration of that compound against NaOH if carboxylic acid group is present. If you think that carboxylic acid may be present, then titrate it against NaOH solution. From here we will get neutralization equivalent. So neutralization equivalent will be calculated after titration. So how we are going to use this neutralization equivalent to find out how many carboxylic groups are present. So for one carboxylic acid group, for one COOH group, neutralization equivalent will be equal to the molecular mass for two carboxylic groups. This neutralization will be equal to molecular mass divided by 2 and so on. So if we know the molecular mass, then we can find out the number of carboxylic groups, and vice versa also. If we know the number of carboxylic groups, then we can find out the molecular mass of the unknown compound. So this is a note point. So this was very important point out of these determinations. So now all of these informations which we have got till now, all of these information, these classical techniques, these were initially used. So that's why we have not gone into the thorough study of each of these methods. Now we will go back to what we studied. We were studying about molecular formula determination. Whatever we were studying, like the qualitative, quantitative analysis, the molecular mass determination, all of that we were doing in order to find out the molecular formula of that unorganic compound, so that we could proceed to find out the molecular structure of that compound. So now our main focus is how to find out the molecular formula once we are done with quantitative, qualitative analysis And once we are done with finding out the molecular mass of the unknown compound, these things are known. Now we'll proceed to how we are going to find out the molecular formula of the compound. So now we will move on to finding out the molecular formula. So till now we have found the empirical formula, right? Suppose we have found the empirical formula using quantitative analysis and qualitative analysis. So first we found the empirical formula using quantitative and qualitative analysis. Then we got the molecular formula by whichever method, any of the classical method or any like mass spectroscopy. So using mass spectra or by using any of the classical methods, suppose we have found the molecular mass of that unknown compound. So now we are having empirical formula and molecular mass. Now oftentimes what happens, empirical formula, this empirical formula weight or you can say mass is oftentimes equals to the molecular mass, but not always, but oftentimes the empirical formula weight or mass is going to be equal to molecular mass of the compound. However, in many cases empirical formula weight or mass, it is less than the molecular mass. In some cases it is equal, and in some cases it is less than the molecular mass. So in these cases molecular weight or molecular mass, whatever we say, molecular weight divided by the empirical formula weight this is going to give us some factor, right? When we are going to divide molecular weight with empirical formula weight, we are going to get some factor, and multiplying this factor, suppose we have got some factor, so multiply that factor with empirical formula weight. Multiply that factor with empirical formula weight. This is going to give us the molecular formula. Now we are going to understand this using an example. So suppose we are having some sort of an unknown compound. We are going to do the quantitative and qualitative analysis, and after quantitative and qualitative analysis, we initially discussed that first we need to do quantitative and qualitative analysis. So we know that the compound has empirical formula CH3 after these two analysis. Now suppose using mass spectroscopy or mass spectrometry, we found the molecular mass of that compound equals to 30. Okay, so using quantitative and qualitative analysis, we found this information, and using mass spectrometry we found this information. Now we want to find out the molecular formula of the compound. So what I have said is oftentimes the empirical formula weight equals to molecular mass. Now if we try to find out the empirical formula weight, so what it will be, for carbon weight is 12 and for hydrogen it is 1. 12 plus 3 will be 15. So empirical formula weight is 15 and molecular mass is 30. So empirical formula weight is less than molecular mass. So what we have discussed here, whenever we are having empirical formula weight less than molecular mass, we are going to divide molecular weight by empirical formula. So we will divide 30 by 15 and we are going to get some factor. Here the factor we have got is 2. 2 multiplied by empirical formula. Just multiply empirical formula with factor. So empirical formula is CH3. Multiply overall this by 2. So it will be C2H6. So the compound is C2H6. So I hope this part is clear, that after getting the factor we are going to multiply the factor with empirical formula, not empirical formula, wait, with empirical formula, and we are going to get the molecular formula. So here we were having the empirical formula is CH3 and molecular mass is 30. So we divided the molecular formula with the empirical formula weight, both the weights, and we got some factor. After we got the factor, what we did, we took the empirical formula and we multiply that by factor like this, and we got C2H6. So this is the answer. This is the molecular formula of the unknown compound. So this is the way by which we are going to find out the molecular formula using all the informations from those 3 steps which we are about to follow. So I hope till now everything is clear to all of you guys and this video was helpful for you. So far that's it for this video. Thank you so much for watching.